What's up, college age people? Here is the key for remote learning, week 3. Instead of having me actually write things down, because that seemed to get a little bit shaky, I was able to make a key, use my phone to scan it, upload the scan file to my computer. So now I've got the handwritten work, which is great, and I can kind of talk over it. So let's see question 1. Remember, these are going to be very similar to the problems you're dealing with, just different numbers. Okay. So with problem number 1, first thing I did is I distributed in this this exponent onto all of the exponents inside the parentheses there, regardless of negatives, positives. The first parenthesis chunk didn't really change, so you notice that is the exact same as what it was, so who cares? Next, once I have all those exponents distributed out, I kept an eye out for negatives. So here you can see the z got flipped to the bottom because we had a negative there. The x to the negative ninth, that got flipped down to the bottom because we had a negative exponent there. Z to the negative ninth got bumped up to the top again because of the negative exponents. Negative exponents just switch the positioning. So then when all is said and done, really the only thing we have left to do is just say, okay, well, what is 3 to the third power? That's 3 times 3 times 3. That's just 27. Number 2 is going to be the exact same process. So distribute into the parentheses any exponents. And if you wanted to, you could simplify the inside of the parentheses first and then distribute later. That's okay. The order is not terribly important, just as long as you get to the right answer, you're fine. Once we have our exponents taken care of, we'll flip things around that are negative. So the 3 to the negative third goes to the bottom. The u has to move. The v has to move. This v has to move as well. So we're flipping things over to the other side of the fraction line. Then with the w's, I see I have 5 w's up top, 3 down below. So after some simplifying, I would have 2 left over after I canceled out. And then v's, I have 3 here, 4 more here. All total, that would be 7. 3 and 4 are the exact same. So because of that, I'm not going to go through 2 more exact problems that you just saw. So reference those. Cool. Next up, distribution. 5 and 6 are the exact same. So I'll kind of talk through 5, and then I'll just show you the answer to 6, and hopefully that'll be good. So on number 5, we had to distribute everything from the first parentheses chunk onto everything into the second. So the w gets multiplied to the 5w, the negative 3x, the negative 7. The 3 goes to the 5w, the negative 3x, negative 7. Once we have all that done, we're going to list everything out, and then we're going to look for combining like terms if we can, and maybe we can't, but if we can, we'd want to. And I'm noticing, hey, I've got a negative 7w and a positive 15w. Those both have a plain old w. Those can combine. Number 6, exact same process. This one's a little bit grosser because you have u's and u's and y's. I can't even read my own handwriting, which can be a little cumbersome to keep track of. All right, next up, factoring. Everyone's favorite F word. Love it. Anytime you have a factoring problem, you always want to start off with a GCF first. So first off, I'll look at my numbers. Is there a number that goes into 12 that also goes into 16? Next, I'll look at letters. Can I safely take a U out of both terms? If so, how many can I safely take away? What about W's? Can I take a W out of each term? If so, how many? Well, I can take away 2, right? Because this one's got 2 to give up. This one's got 9, so it can spare to lose 2. I can't take any Y's out because this one doesn't have any Y's over here, so that would be off limits. So my GCF would be a 4. I can take out a U, and then I can take out a W squared. That would be my GCF. Then I have to figure out what would I be left with. If I divided out a 4UW squared, I'd be left with 3y to the 5th. I divided 12 by 4, took away 1 of the u's and 2 of the w's here, and then that's what I'm left with. Similarly, on the 16, I divided by 4, took away 1 of the 6 u's, so I'm left with 5, and took away 2 of the 9 w's, leaving me with 7. Next up, factoring trinomials. We have seen these time and time again. This is just straight up a matter of practice. When we factor our trinomials, the first term gets split apart into the first terms of each parenthesis chunk. Fortunately, 3 is prime, so the only way we can get a 3 is just 3 times 1. And since there's an x squared, 3x squared times, 3x times 1x. 16, we have a few more options. It could have been 1 and 16. Maybe it was 2 and 8. Maybe it was 4 and 4. For this one, it happened to both be 4s. And then when we double check, you always have to check for the middle term. We want it to be 16. So 3 times 4 is 12. 4 times 1 is 4. 12 and 4, yeah, that makes 16. Same exact concept now for number 9. What multiplies to be a 5? Well, 5 and 1. Then how do I get a 15? It's either 1 and a 15 or a 3 and a 5. So for this one, again, we want to double check for the middle term. 5y times 5, that's 25y, and a negative 3y. Yeah, that would give me a 22y. Number 10 is going to be the exact same as numbers 8 and 9, only now we've got a GCF first. Well, I could take out a 4u squared from everything, and then I'd be left with 2u. Oops, this should be a u squared. I done did goof. Perfect. 2u squared minus 7u plus 5. So then that is the part right here that we are trying to factor out. So that factors down into those components there. Neat. All right, next up, factor by grouping. This is something that you guys have seen a while back, but it's kind of a special case. We don't really use it a whole lot. Factor by grouping is great if you have an even number of terms. In this case, we have 4 different terms. That's an even number. So what you're going to do for factor by grouping is you're going to take, let me see if I can get this here. You're going to take only the first pair, the first grouping, and say, okay, what is the GCF there? And then do the same thing of the second pair, the second grouping, say, what is the GCF there? So when we do that, I'll notice the GCF of the first group would be a w squared, leaving me a 3w plus 5. A GCF from the second group would be a negative 3. If we start off with a negative, we're going to want to factor out a negative. Easy way to tell that we're doing this probably correctly is the stuff inside the parentheses matches. So they're both 3w plus 5s, which should be an alarm in my head that we're doing this correctly. So this would turn into w squared minus 3 times 3w plus 5. If you can continue to factor this down, you need to do so. So if I see a w squared minus something, my brain immediately goes to difference of 2 squares. I can't take the square root of 3, so that's not going to work. Question number 12. Always look for a GCF first, in this case, 2v to the third. Now I've got this x to the fourth minus 1. Well, that's a difference of 2 squares pattern. So that actually factors down into conjugate pairs. So this part here factored down into conjugate pairs there. But this can actually continue to go further because I can continue to factor x squared minus 1. That's another difference of squares pattern. And that would be x1 x plus 1 times x minus 1. Number 13 is going to be the exact same concept. Get a GCF out first. Notice, hey, there's a difference of squares thing going on. And yes, the order is important. Here, the constant comes before the variable. That has to always be true. So they have to match whatever order they're originally in. Then we continue factoring conjugate pairs where it applies. All right, problem 14, we need to solve. Anytime it says solve, we should have an equal sign in our final answer. Well, I can use the zero product property here and set each parenthesis grouping equal to 0. So 1 minus, wow, how did I get that wrong? I just noticed a mistake. Eesh. That should be y equals 1. 1 minus y equals 0, and then 2y minus 7 equals 0. Solve each one of these for y, and there you go. Number 15, you have to factor it first. And then once it's factored, set each independent factor equal to 0. Number 16 is kind of cumbersome. First thing you got to do is distribute that w minus 2 out, and then you're going to need to set everything equal to 0. So w minus 2 quantity squared is really w minus 2 times another w minus 2, and this is what we result in. Then we want to set everything equal to 0, so I'm going to stack everything over to the right-hand side. So I moved the w squared over, added the 4w, subtracted the 4. And then we factor, and once it's factored, we can go ahead and solve. Remember, we like these to be equal to 0 when we solve them. Problem number 17. Compute the value of the discriminant. Well, the discriminant is just part of the quadratic formula. If you don't remember the quadratic formula, here it is. Negative b plus or minus square root of b squared minus 40cl over 2a. The chunk that is underneath the radical, that's what's called our discriminant. And really our discriminant is good for one thing and one thing only, and that's just how many solutions can I expect. If my discriminant is any positive number, I'm going to expect 2 solutions. If it's a negative number, there's no real solution, and it kind of makes sense. I don't take the square root of a negative number. And if my discriminant is exactly 0, that means there's exactly 1 solution to the quadratic here. So they give us an equation set equal to 0. I listed out my a, b, and c values here, and then it just comes down to plugging in, 8 is b, negative 9 is a, negative 2 is c. Plug those in and throw it right into the calculator. My discriminant is negative 8. Well, since my discriminant is a negative number, that means I have no real solutions. Problem number 18. Sorry in advance for the lack of space on this one. The area of a rectangle is 65 square feet, so area is length times width, and they're telling me the area is 65, so 65 equals length times width. But the length of the rectangle is 3 less than twice the width, so length equals 3. Oh man, I goofed on this one too. Holy smokes, people. So this should actually be 2w minus 3. So I goofed on that, which means the rest of the answer is going to be wrong, but it will follow a similar pattern. So we will substitute in for length, our second equation. Then we have some distribution to do. Once we've distributed, we want to move things over to the other side of the equal sign so that it's equal to 0. I guess when I made the key, I maybe figured out that I screwed up because negative signs weren't matching. Interesting. Once we have it equal to 0, we can go ahead and factor. Once we have it factored, we can go ahead and solve. So you're going to want to take the more realistic answer. A lot of times you'll have one positive, one negative result. Negative dimensions would not make sense. So if my width here, after solving for w, is 6.5, that'd be 6.5 feet. I'd plug that into my length equation, and I would get 10 feet for the length. All right, numbers 19 and 20, they're going to be the exact same style of problem. We have a model rocket is launched with an upward velocity of 151 feet per second. We want to know what is the height after, at what value for t, so at what time is the height 88 feet? Well, if I kind of think about the trajectory, it's going to go up and then come back down, and 88 feet might be like right there. So it'll probably hit it in 2 separate spots. When we do this, all we have to do is just set this height value equal to whatever the height is. And then we'll set it equal to 0 and rearrange it so it's in order. And now this looks pretty user-friendly for quadratic formula. Negative b plus or minus square root of b squared minus 4cl over 2a. We'll get 2 answers. You're going to want to ignore any negative answers because it wouldn't make sense for a time value to be negative, right? We're not going back in time. So after we plug negative 16 in for A, 151 in for B, negative 88 in for C, we would get the following 2 times. And like I said, that kind of makes sense, right? It would go up past 88 and come back down through 88. As promised, number 20 is the exact same concept. Set it equal to the height and go from there. Let me know if you have questions.